Okay, looks like it's time to get started. Thank you everyone for joining our live lecture today. My name is Isaac and I'll be the lead instructor for the lecture. And today's topic will be web security. So diving right in, let's go ahead and talk about your mindset when it comes to web security. Okay, and your mindset should be prepare for the worst and hope for the best. Okay, so before you start building any web project, you should always first determine the level of security that's needed. For, say, a static menu website at a local restaurant, there wouldn't be a high need for security because there's not that much sensitive information involved. Whereas if you had, say, an e-commerce website with passwords and payments and credit cards involved and such, then you would definitely need a higher level of security. So definitely don't, approach all of your projects the same when it comes to your levels of security, because it definitely is based on the project itself. Okay, next, let's talk about developer accountability. Okay, so as a developer, you must be aware that you're bound by certain laws when building projects within specific scopes. Okay, so first we'll talk about PCI compliance, and this is the handling of credit card data. Okay, so if you need to come check out the latest regulations on that, you can come to PCIsecuritystandards.org. Okay, and then we've got HIPAA, and HIPAA is the handling of health data. So if you're involved with software that is handling, sensitive information in that regard, then you would, excuse me, come to HIPAA's cybersecurity section and read the latest regulations. Okay, so next, let's talk about building your security around actors. Okay, so as a software developer, it's really hard to sit there and just, think of all the different, bad guys that could, potentially try to infiltrate your app. Okay, so instead, try to think of things in terms of good actors and bad actors. Okay, so a good actor would be someone like a user of the website that uses it for its intended purpose, like a customer or a seller. And then a bad actor would be someone who uses the website for its own intended purpose, maybe an employee that hijacks customer payment info, hacker posing as a customer, those kind of things, okay? And you think of that aspect, it's a little easier to build your security as you build your app out. So next, let's talk about trust boundaries. So trust boundaries are divisions between areas of software that have different privileges. Okay, so we've got client-server roles, network machine boundaries, encrypted channels, authentication, and areas of responsibility within a system. Okay, so let's go ahead and go over each of those. Let's start with defining what is a computer network. Okay, so a computer network is a collection of computers connected by a transmission medium. When you write software for the web, it will end up being hosted on a web server. Clients then may connect to your server via web browsers, native iPhone and Android apps, and anything else capable of sending network requests. Okay, and while this is a great thing, it connects the world together, it also kind of opens up a back door for hackers, okay? And so anyone in the same network as you can view all the traffic that you're sending and receiving. So in order to have a private conversation between your client and servers, the channel must be encrypted. And this can be accomplished by using a TLS certificate and redirecting our web traffic from HTTP to HTTPS. Okay, and so some TLS certificate providers, there's a couple right here. We got Symantec. Okay, and then we've also got Komodo. Okay, and like I said, that's just a couple of them. There are a lot more providers you can choose from if that's what you want to do. But those are kind of a couple of really popular ones. All right, next let's talk about API security in regards to your endpoints. Okay, because endpoints are generally publicly exposed, it's a good idea to set up some additional logic to verify the incoming API request. So, for example, GitHub.com does a really good job of this. When you first go to GitHub, you're a guest, you're unauthenticated. And so they allow you to look at other people's resources, but none of your own, because obviously you don't have an account. And then once you become an authenticated user, you can look at your own resources as well as public resources. And then if you maybe have a role authentication involved, it can even share those resources as well. Okay. So continuing on the topic of API security, let's talk about rate limits now. So imposing a rate limit for requests made to your application API is a good way to ensure your site from getting hacked with several requests at once. So let's take, for example, this line right here. This request will send to GitHub, and GitHub has a rate limit. And so we can see that we send off that request, and it starts at the limit of 60, and after I sent the request, it goes down to 59. Okay, so this is the way we can protect our endpoint from, again, getting flooded with too many requests at once, okay? And so next, let's go ahead and let's talk about some vulnerabilities, okay? So we'll start with the DOS attack. And the denial of service attack is typically accomplished by flooding the targeted machine or resource with many requests at once in an attempt to overload systems and prevent some or all requests from being fulfilled. Okay, and so this goes back to what we talked about a minute ago. If you don't have any rate limits, nothing like that, and put, set up, then you're open for a DOS attack in that regard. Okay, so prevention methods for this kind of attack, we've got throttling, which is limiting bandwidth, rate limiting, which we saw a minute ago, which is limiting the amount of requests that can be made, from a single IP in a given amount of time, and then web traffic monitoring, where we can see spikes in traffic and take action immediately rather than finding out the next day or something like that. Okay, let's talk about another kind of vulnerability, the XSS attack. So cross-site scripting is a type of computer security vulnerability typically found in web applications. XSS enables attackers to inject client-side scripts, typically through an input of sorts, into web pages viewed by other users. Okay, and then of course they're running scripts in your program, and that's not good. So to prevent against this, we can use something called sanitization. Okay, and sanitization will basically scrub our inputs for specific data types and make sure only those are passed through. Okay, next vulnerability. Let's talk about SQL injection. Okay, so SQL injection is a technique to use is a technique used to attack data-driven applications in which nefarious SQL statements are inserted into an entry field for execution. Example given, to dump the database contents to the attacker, right? So to prevent against this, we can use sanitization, right? We can scrub our inputs, make sure it's a specific data type. And we can also use what's called an ORM, an object relational mapping tool. And, this will just, increase our security in that regard as well. Okay, next vulnerability we'll talk about is a file upload. Okay, so one of the most commonly exploited web vulnerabilities is unrestricted file uploads. This can allow an attacker to upload an executable file, such as a PHP file, then call the corresponding URL from the web browser. They are now running code on your server. Okay, so to prevent against this, you can use a file type detector. And that way you only allow certain file types, such as maybe images or something in that regard, and you disclude any other extensions. Next vulnerability we'll talk about is ARP spoofing. Okay, so ARP spoofing is a technique by which an attacker sends a spoofed address resolution protocol into an area, messages onto a local area network or LAN. And generally, the aim is to associate the attacker's MAC address with the IP address of another host, such as the default gateway, causing any traffic meant for that IP address to be sent to the attacker instead. Okay, so this is very much like an interception that way. So to prevent against this, once again, we see the TLS certificate. Okay, so we purchase that and redirect our traffic from HTTP to HTTPS. Next, another kind of vulnerability is called DNS spoofing. Okay, and it's a form of computer security hacking in which a corrupt domain name system data is introduced into the DNS resolver's cache, causing the name server to return an incorrect IP address. This results in traffic being diverted to the attacker's computer or any other for that matter. Okay, and typically this is a lot less common because your DNS provider typically has pretty good security measures in place, but to be safe, you should use, once again, a TLS certificate to prevent against this kind of behavior. Okay, that's enough about vulnerabilities. Next talk about some defenses. Okay, so one of the most commonly known kind of defenses is called a firewall. Okay, so firewall is simply a network security system that monitors and controls the incoming and outgoing network traffic based on its predetermined security rules. It's always a good idea to make sure that the machine your server is running on has one set up. Okay, and so, you know, these days a lot of people run on cloud servers, you know, things of that nature, right? But you know, if you happen to have a local, you know, server, you definitely want to, you know, set up a firewall and regulate traffic. Next, let's talk about having a plan B. Okay, so as you can see, you know, there's a good amount of vulnerabilities out there. So, you know, it's good to keep in mind that no system is 100% completely secure. So you need to do a couple things. You need to back up your data and back up your operating system, just in case your service goes down, it's not interrupted for your end users. As well, you should also have an emergency checklist in place in case of a service outage so that corrective action can be taken immediately upon discovery of the issue. Okay, so the longer you wait, the more damage will be done. So this is where having a checklist to refer to is going to save you a lot of time and effort. Next, let's talk about organizational privileges. So as there's oftentimes a large number of hands involved with building a single software project, it's a good idea to restrict access to things on an as-needed basis. For instance, a developer may have access to modify the code, but not to touch the production servers. And the operations team may have access to modify the server environments, but not the code. Okay, and that's because, you know, people quit, people get fired, there's a lot of things that happen, right? And the last thing you want to do is have one of your employees delete your database or something else where, it's irreparable damage. So that being said, don't just give full privileges to everyone, give them out as needed. Now we'll move on to the topic of protecting passwords. And before I start this, I want to preface with the fact that there's many ways to protect passwords, many ways to encrypt them. This is just one approach. Okay, so we're going to teach you the salting and hashing approach. Okay, so this is, different between different, languages, of course, but the concept's, overall the same. So when encrypting passwords, we first add a salt, a long random sequence to the password, and then we hash it. And that algorithm, jumbles that up, and it's used to verify that the block of content hasn't changed. And this does a couple things. It makes it impossible to guess the password without knowing the salt. And even if the attacker gains access to salt, they won't be able to use the pre-computed hash tables to get the password out. They'll have to compute the entire space from scratch. Okay, so as well as encrypting your passwords, it's also a good idea to enforce a password strength rule, right? A lot of us have seen these where it's a minimum of 6 characters, or maybe they require you to have a special symbol and a number, right? So, the more, complex, the better in that regard. All right, next let's talk about two-factor authentication. Okay, so simply asking them for maybe username, password, that kind of stuff, that's just, one-factor authentication. But in the event that maybe you ask them to log in, and then after that, you send a code to their phone and have them use that code to get to the next part of the program, then that's two-factor authentication. And a lot of us have experienced that before. Usually, really sensitive financial institutions like banks, they'll use two-factor authentication, and others as well, because it's really hard to get around, because if the attacker says, or if the attacker picks up maybe your laptop on the subway or the train, and they try to get into your account and there's two-factor authentication, well, then they have to have your computer and your cell phone, right? And that's going to be really hard to compromise more than one device at a time. So moving on, let's wrap up with the topic of security resources. Okay, so you're only as strong as, you know, the current updates and knowledge that is out there, and you use it. So that being said, here's a couple resources we recommend to keep up to date with all the latest reports on attacks and how to prevent them. Okay, so this NVD here is you know, a government maintained database, and you know, it's pretty self-explanatory. Just, you know, has lists of vulnerabilities and recent updates, and, you know, the level of severity and all that great stuff. So another good site is OWASP, and this is like a kind of like a Wikipedia as you search through kind of archives of you know, security, you know, measures and practices. And then we've got Verus, and Verus is similar to NVD. It's a, you know, a database, except it's community, you know, maintained, and instead of government maintained. Let's go ahead and let's open up the floor, and let's see if anyone has any questions. Okay, so the floor is open. If you have questions, feel free to ask them now. Okay, I don't hear anyone, so I'm assuming we're all good so far. So if that's the case, then we'll go ahead and end our call. Thanks everyone for stopping by, and happy coding out there.